Okay, hi. So let's talk about physics. Well, if we want to talk about movement, of course, every object in the entire universe is moving around some point continuously. So that's very important to know about position, velocity, displacement, and time. Okay. So at this video, we are going to start to know some concepts we need to understand everything about movement. So the first question is where and when? Where and when will be answered with position and time. So let's begin with using our imagination, okay? Is it possible to measure distance and time on a motion diagram, for example? Okay, so imagine that you will photograph a runner, okay? Before photographing the runner, you could place a long measuring tape on the ground to show where the runner is in each image. A stopwatch within the camera's view could show the time. Okay, so I will share my imagination over here. Okay, that's it. So let me see. First part. Okay, this will be the first part. So we have our runner, a long measuring tape on the ground. Every 5 meters will be a point of measurement. Okay. So 0, 5, 10, 15, 20, 25, 30. I will put two different objects, like a cactus and a lamppost. Okay. And we are gonna talk about the objects, the runner, and the measuring tape. And of course, the stopwatches. But right now, they are not in the image. Will be show you them later, okay? So if we talk about position and time, okay? Position and time is useful to identify a system in which you have chosen where to place the 0 point. Okay, and 0 is with a, okay, yeah, 0 point of the measuring tape and when to start the stopwatch. So 0 point or origin is a very important concept. Okay, so a coordinate system gives the location of the 0 point of the variable that you are studying and the direction in which values of the variable increase. Okay, so back to the imagination picture that I have here. So For example, we look at a simplified motion diagram that uses dots to represent a moving object and arrows to indicate positions, right? Okay, so that will be a coordinate system. So coordinate system, okay? Okay, so the origin is the point at which all variables in a coordinate system have the value 0, okay? In the example of the runner, the origin is 0 point of the measuring tape because the motion is in a straight line. Your measuring tape should lie along this line, okay? So back to the imagination. Yeah, it's a straight line. It's a straight line. We have a 0 point at the beginning. Of course, that will be the origin, 0. And the runner, of course, will be moved to the right. Okay. So if we talk about distance, distance is the entire length of an object path, even if the object moves in many directions. Is there such a thing as a negative position? Yes. You can move to the left from 0 point. And I will show you that on my imagination. So look at this. I have 0 point, my origin, and position can be negative if I move to the left from that origin point, okay? So if I choose a point in the space and I decide to put all positions to the right of this point, like positive, yes, we can do that. But of course, if I want, all points on the left side will be negative from the origin if I want, okay? I choose my coordinate system. So an easy way to understand this is that always points from the left or the origin will be negative, and points on the right side will be positive. Okay? Good. Very good. Okay. Now, if we're going to talk about vectors and scalars, so this is very important because in physics, we have both quantities, vectors and scalars. There are many kinds of measurements and numbers used to represent or describe motion. If you needed to describe how far you run, you might say that you run, for example, 1.6 kilometers, right? Okay, that will be an example. Okay. If you needed to run to a specific location, you might say that you need to run 1.6 kilometers north, okay? Now we have a direction after the 1.6 kilometer. So quantity that has magnitude, okay, remember this, magnitude is a real number and a unit, okay? A real number and a unit, that is magnitude. And next to the magnitude, we have a direction, okay, that will be called a vector, okay? You can represent a vector with an arrow. That is very important, okay? An arrow. Let's do next graph. Let me see if I can share my, okay. Oh, there it is. Yeah. I will share my screen to you. Okay, there it is. So a vector is represented by an arrow. Okay, I can put on the next screen or page an arrow. That will be a vector. But look at this. This is a vector code A. Okay, from now, a vector, the algebraic representation of a vector will be a letter, and above the letter, we will have an arrow. Okay? If you look, the length of the arrow represent the magnitude. Represent the magnitude. Okay, so this arrow can be 5, for example, on the screen, but if I want, can be 10. Okay, the length will be the magnitude. Can be 15 or 20, for example. Okay, and I can draw another vector, but in a different direction. To the left, for example. Okay, and of course, if I want a magnitude of 10, okay, I will put the front of the arrow on 10 on the left, 15 or 20. That will not be a problem for us, okay? Good. Of course, we can get a vector in the y-axis. Okay, so that will be a vector d that points to the y-axis with positive values, and an e vector, let me see. Okay, an e vector that points to the y-axis, but a negative values. Okay, that will not be a problem for us. Okay, excellent. So remember, the length of the arrow represents the magnitude, and the direction of the arrow represents the direction of the vector. Okay, a quantity that is just a number without any direction is called a scalar. Is called a scalar. Okay, remember that. The scalar without a direction, vector, of course, it has a direction. Okay, good. If we want to talk about time intervals are scalar, okay, time will be an scalar. Okay, when analyzing the runner motion, you can obtain this value by finding the difference between the stopwatch reading at the cactus, for example, and the stopwatch reading on the lamppost. Okay, look at this. I will share my imagination again. Okay, there it is. So remember this. Our imagination at the beginning of this lecture, okay? We have the runner at the 0 point. Of course, look the stopwatch. Of course, at 0 point, time that will be 0, 2. Okay? At 5 meters will be the cactus from the origin point. But if you can see the stopwatch, the measurement is 1 second. Okay. Yeah, of course, the lady continues running across the straight line and arrive to the lamppost 25 meters from the origin point. Okay, that will be the distance between lamppost and the origin. But if you look the stopwatch, it appears to be 5 seconds. Okay, 5 seconds is the time that she needs to arrive to the lamppost from the beginning. Okay, so the difference between two times is called time interval. Okay, so for example, the time interval between the lamppost and cactus will be 5, okay, 5 minus 1. 5 minus 1 will be 4 seconds. Okay. A common symbol for a time interval is delta t, where delta is a Greek letter. It is used to represent a change in a quantity. Let TF represent the final or ending time of the interval when the runner was at the lamppost, for example, and TI will be the initial or starting time. So delta T will be the T final or the final time minus the initial time or TI. Okay. So the time it takes for her to go from cactus to lamppost is TF minus TI, will be 5 minus 1, and that will be 4 seconds. Okay. Okay, position and displacements are vectors. Okay, so they need a direction. You have already seen how a position can be described as negative or positive in order to indicate whether that position is to left or to the right of a coordinate system origin. Position is a vector, okay? So back to the imagination. Okay, so for example, here, a position is a vector with a narrow tail at the origin of a coordinate system, right? And the arrow's tip at the place or the final point in your coordinate system. Okay, so look at this. XF will be the final position of the runner after 25 meters. And XI will be the initial position of the runner, okay? So my initial position is cactus, for example, and my final position will be lamppost. So if I want to calculate the difference between final and initial position is delta x, will be the rest of these two different x, final x minus initial x. Okay. So delta x represents the change in position from the cactus to the lamppost. Okay, from the cactus to the lamppost. If I want to calculate the change in position from the origin to the lamppost, for example, okay, of course, initial x will be 0, right? Because my initial position is 0, the origin. But in this case, initial position is cactus. So initial position is cactus, and final position is the lamppost. So the change in position between these 2 points on space will be delta x. And a change in position is called displacement. Okay? It's called displacement. By looking at figure, you can see that this displacement from the cactus to the lamppost is 20 meters to the right. So final x, the final position, and initial x is the initial position, and delta x will be final minus initial. So that will be the displacement between cactus and lamppost. Okay. Okay. And look at this. A plus or a minus sign might be used to indicate direction. Okay. Remember that the initial and final positions are the start and the end of any interval you choose. Okay. So back to the coordinate system I have here. Okay, look at this. For example, if this vector A is a position of 10, okay, 10 meters or 10 centimeters, whatever you want, okay, it's 10, okay, I can draw another vector, but an opposite direction. For example, okay, A will point to the x negative, and that's B, sorry, and A will be pointing to the x positive. Okay. So, for example, this A, if A represents a position, that will be positive, a positive position, okay? And B will be a negative position because it's pointing to the x negative, okay? So positive position, negative position. And yes, if you are asking yourself that we can do an addition or a subtraction of vectors, the answer is yes. Okay. Okay. The answer will be yes. Yes, you can do addition and subtraction of two different or more vectors, right? And we're going to talk about this right now. Subtraction and addition. Okay. So back to the paper. Okay. You will learn about many different types of vectors in physics, including velocity and momentum. A vector that represents the sum of two other vectors are called a resultant. Okay. That will be a resultant. So for example, okay, example or examples, okay, of vector addition, vector subtraction, and let me see. Okay, I'm gonna show you the exercise. So at first, I got an example of vector addition. Okay, you have the origin, that this will be the origin. Okay, I don't know, a car, a guy, a child, walk 5 kilometers to east, arrive, I don't know, to his house or her college, I don't know, any point in the space, but continues walking by 2 kilometers east again. Okay, so that will be easy. The resultant, that will be an R with an arrow, will be A plus B. Okay, 5 plus 2, and that will be 7 kilometers. Yeah, 7 kilometers to the east. Okay, because that movement points to the east. But in case of subtraction, okay, they can be, first, you walk 4 kilometers to the east, but then, I don't know, you forgot to visit your grandmother, for example, and you have to return to the west direction, but on a distance of 6 kilometers. Okay. Oh, okay. Let me see. 4 kilometers to the east, 6 kilometers to the west. Yeah, of course. They point on different directions, right? Okay, so 4 minus 6, because the directions are totally opposite. Okay, so 4 minus 6 will be minus 2, and that minus, or look at this, that minus will represent 2 kilometers west. Okay, this minus will be west. This plus in front of 7 will be east. That will be our conversion with a sign and a particular direction that I choose. Okay, so positive will be east, negative will be west. Oh, look at this example. Okay, origin. Okay, I walk 7 kilometers to the east, but I turn back 4 kilometers to the west. Okay, 7 minus 4, that will be 3. Okay, 3, but it's a 3 positive. So if the subtraction over here between these two quantities is a positive number, that represents that the final position of the resultant vector will point to the east. Yeah, to the east. So remember, positive, if the resultant is positive, that means that the direction is to east, okay? And that's it. It's great. So let me see. I will show you at this program, okay? I have a vector of 10 to the right, yeah? And a vector B, and points to the X negative, okay? So if I do zoom, okay, zoom will be, yeah, that blue arrow that we have here, okay? S will be the resultant. Okay, yeah, of course, 10, let me see, 10 minus 5, that will be 5, positive. Oh, yeah, of course, the resultant is 5, positive. So it's 5 that points to the right or to the east, for example, because subtraction is positive between A and B vectors. But what happens if I do V magnitude a little more? Okay, 10 and 10, yeah, of course. 10 to the right and 10 to the left, the subtraction will be 0. 10 minus 10, 0. There is no resultant. But if my V vector is greater than A, oh, look at this. The resultant will point to the west directions, to the negative X. Why? Yeah, the reason is that the V magnitude is 15 units, okay? 15 meters, 15 kilometers, 15 gigameters, whatever. And vector A, its magnitude is 10. Okay, so 15 minus 10, or 10 minus 15, okay, look at this, 10 minus 15 will be minus 5, okay? Okay, minus 5, because 10 minus 15 is minus 5. Minus 5, the resultant vector, that minus represents that vector will be to the left, or to the west, or to the X negative. So back, look at this. If I do my vector V a little bit more little, okay? If I do vector little and the magnitude of both are 10, so resultant will be 0. If I do this a little bit more little, for example, okay, my resultant vector will appear on the right axis. Yeah, of course, because A minus B, A is greater than B on magnitude, so the resultant will be on right direction. Yeah, look at this. And for example, if here I am doing addition, right? Two different vectors, A and B, but in this time are going to the right direction. So of course, that will not be a subtraction, it's an addition. So A plus B will be the resultant. This little guy over here, all these will be the resultant from origin to this point. So of course, 10 plus 10, 20. And that's it. We can do addition or subtraction on vectors. Excellent. Now I will finish here. Great. We talk about time, distance, displacement, position, and addition and subtraction of vectors, right? So, bye.